Hello friends, continuing with the instructional videos on the 100 inverter from the LS brand. In previous videos we covered how to start and stop from the keypad, set the frequency from the keypad, set the frequency via analog voltage input 0 to 10 volts, and set the frequency via analog current input 4 to 20 milliamps. Today we want to set the frequency for the 100 inverter via the network and also perform start and stop through the network. Specifically, today we want to connect the 100 inverter to an HMI using the Modbus-RTU protocol over RS-485, and in this way send the frequency value to the inverter and perform start and stop operations through the network and the HMI. In previous videos, we mentioned that if we want to perform start and stop of the inverter from the keypad, we need to set the diav parameter in the operation group to 0. Today, we want to do this through the network, meaning we don't want to use those red and green buttons on the inverter's keypad to start and stop it. Instead, we want to perform start and stop through the network and using an HMI. So, in order to start and stop inverter 100 via the network, in order to set the frequency reference to the network, meaning to set it to the RS-485 network and send the frequency value to the inverter via the network, we need to set the FRQ parameter in the operation group, which is the main group, to the value 6. But what will our wiring look like? Here we have a high-tech HMI. In the high-tech HMI, COM2 is dedicated to RS-485. On this S100 inverter, the S plus and S minus terminals are for the RS-485 network. On the high-tech HMI COM2, there is an A terminal, A positive, and a B terminal, B negative. The A positive terminal connects to the S plus terminal of the inverter, and the B negative terminal connects to the S minus terminal of the inverter. Well, after we've done the wiring, what settings do we need to configure on the S100 inverter? And what are the addresses related to the RS-485 network and the Modbus-RTU protocol for this inverter? Let's check the manual along with this music to review the addresses and parameters. Okay? To configure the network-related parameters on the S100 inverter according to the manual, we need to enter the CM group, which is the communication group. The parameters we need to set for the RS-485 network. The first parameter is the inverter ID or station number. To set the station number on the S100 inverter, we enter the CM group and specify the station or inverter ID in parameter 1. The second setting we need to do is in CM2, where we select the protocol for our network. If it's set to 0, the protocol is for the same Modbus-RTU. If it's set to 2, that's LS bus, which is for devices that are from the LS brand itself, and if we want to network LS brand devices together. Here we want to establish this connection via Modbus-RTU, so we set it to 0. The next parameter is the baud rate, which is the data transfer speed. In parameter COM03 or CM03, we set the baud rate, and in parameter CM04, we specify the number of data bits, parity and stop bits. So these are the settings we need to configure on the S100 inverter. Now let's move on to the addresses. The addresses that exist in the S100 inverter or in most LS brand inverters, you need to go to the address map section in the manual and read the network addresses there. For example, as you can see here, the frequency command's address in hex is 0x05. This means that if you assign address 5 to an analog input or an analog display, you can both read and write the frequency value. For start and stop as well, you can see that the operation command's address is address 6, meaning if you assign it to a switch or a push button, and as you can see here, if you assign address 6 and bit 0 is activated, it means stop. If bit 1 is activated, it's forward, and if bit 2 is activated, it performs the reverse operation. So as we saw in the address map, the address for frequency is hex 5, and the address for start stop is hex 6. If bit 0 of address 6 is activated, the stop operation occurs. If bit 1 is activated, it's forward, and bit 2 is for reverse. So these are the addresses related to the RS-485 network communication. But let's move on to the HMI. In the High-Tech Studio software, as you know, which is related to high-tech brand HMIs, here we've placed a numeric input, and as you can see, we've assigned it address 4. Why did we assign address 4? In the RS-485 network under the Modbus-RTU protocol, for some devices and some connections we establish with certain brands, we need to subtract 1 from the main network address. We said that the address for frequency in LS inverters is 5, so if we subtract 1, it becomes address 4. So I placed a numeric input for the frequency value, both for reading and writing it. I also added a switch and said that if setup set to constant, we said that if we want the forward operation to happen, bit 1 of address 6 must be activated. Here, I subtracted 1 from the address, set the address to 5, and set the value to 2. Bit 1 is 2 to the power of 1, which is 2. So if you give the value 2 to address 5, the forward operation will be performed. For stopping, we said bit 0 must be activated. Bit 0 is 2 to the power of 0, which is 1. So you need to give the value 1 to address 5. That covers start and stop, and also the frequency value, which was address 5. We subtracted 1 and gave it address 4. I added a fan so that when the inverter starts, the command is sent to this fan and my fan starts, and when it stops, my fan also stops. Here, I also send the frequency value to the inverter. Let's go to the device and first set all the parameters we mentioned and then test these settings together with the HMI. Okay, we set that for start, stop to be controlled via the network. We need to set the DRV parameter to 3. We enter it, set it to 3 and confirm. For the frequency value to be set via the network, we said the FRQ parameter in the main group should be set to 6. We go to the FRQ parameter, set it to 6, and confirm. Now the other parameters we need to set are station, baud rate, parity, stop bit, and the number of bits. We said we need to enter the CM group and set these parameters. I enter the CM group. CM1 is for my station. You see its value is 1, so my station ID is 1. CM2 is for my protocol. We said if it's set to 0, my protocol is Modbus-RTU, we confirm it. CM3 is for my baud rate. It's set to 3, which means my baud rate is 9600. These are the settings we made on the inverter. Now, let's test all the settings we made together on the HMI. Now, I want to set the frequency value on the inverter via the HMI. For example, I set it to 20. You can see that after confirming, the value 20 also appears on the inverter keypad display and is set on the inverter. When I press the start button, you can see that my fan starts working. My inverter starts in the forward direction. If I press the stop button, my fan stops and my inverter goes into stop mode. For example, I set the frequency value to 50. My inverter was set to 50. I start my inverter again, the fan started working and my inverter started again. I press the stop button again and you can see that my inverter went into stop mode. So in this tutorial video, we learned what settings we need to make on this inverter 100 so that we can both start and stop it via the terminal as well as set the frequency. We also learned the terminal addresses on this inverter 100 related to frequency and start, stop together.